Hello everyone. In this tutorial, we're diving into the extended Euclidean algorithm using JavaScript. Now this method doesn't just calculate the greatest common divisor or GCD, it also gives us coefficients that satisfy Bezout's identity. A times x plus b times y is equal to GCD a and b. It is super useful in number theory, cryptography, and modular arithmetic. Let's take a look at how it works and build the function step by step. So what's the goal here? We want to find the GCD of two numbers, like 17 and 4, but also figure out two integers, x and y, such that 17 times x plus 4 times y is equal to the GCD. In our example, that becomes 17 times 1 plus 4 times negative 4 equals 1. This technique is foundational in solving modular equations and inverse problems. Let's move on and break down the code. Let's walk through the function. We first sanitize the input. We make sure that a and b are finite numbers and integers. We then initialize some helper variables that will track our coefficients. Inside the loop, we perform Euclidean division to compute the remainder, and we update all values to trace the coefficients. When a reaches 0, b holds the GCD, and x and y are our final coefficients. We adjust the sign at the end and return GCD, x and y in the array. The process follows 5 logical steps. We check for the bad input first, then we set up a few variables that will evolve as we loop through Euclid's method. Each iteration reduces the problem while adjusting the coefficients. And then once the remainder hits 0, we know the GCD, and the current coefficients satisfy the equation a times x plus b times y is equal to the GCD. This structure is elegant and super efficient. Let's test the function. With inputs 17 and 4, we get the array of 1, 1 and negative 4. And sure enough, 17 times 1 plus 4 times negative 4 is equal to 1. It works for all kinds of integer pairs. This function is accurate, fast, and helps us do more than just find the GCD. We get a full equation result. This algorithm has deep roots in real-world applications. It is essential in cryptography, like when finding modular inverses in RSA. It is also used for simplifying fractions and solving Diophantine equations. And if you're into coding competitions, this is the must-know pattern. To recap, we've implemented the extended Euclidean algorithm using JavaScript. It not only gives us the GCD, but also the integer solution for a times x plus b times y equals to the GCD. This is one of one of those core functions that powers everything from math apps to cryptographic tools. Hope you learned something cool today. See you in the next breakdown. Thank you for watching. If you enjoyed this video, please make sure to like, share and subscribe for more JavaScript tutorials. I'll see you in the next one.